Hi, everybody. Welcome to this AWS webinar. I'm here with my colleague, Ryan Demick, and he will be talking about how to architect resilient and scalable solutions on AWS here in just a moment. Just want to welcome everybody, and also thanks, Ryan, for being here, and thank you all for joining us as well. My name is Anne, and on behalf of Excel Instructor-Led Training, I'd like to welcome you to this webinar. And just in case you didn't know who we are Accelerate, Exit Certified, and WebAge Solutions, and among us, we have more than 60 years of experience in the IT training business, which is great news for you because that means you get access to all of our certificates, all of our partners, curriculum, trainers. We do have a little nuances here and there. Accelerate focuses on customized courses for teams. Exit Certified has all the vendor authorized certification courses, and WebAge Solutions focuses a lot on upskilling programs for entire organizations. Exit Certified and WebAge also has public online courses. We do teach a lot of AWS, all three of us do, plus a lot of other technologies, but it doesn't matter who you contact. We'll get you the right people and we'll get you the training that you need. And speaking of training, we are running an Architecting on AWS course that maps very well to this webinar. It will be a live public course running November 19th to the 21st. So it's 3 days, live, instructor-led, hands-on. And we are offering for these dates a 60% off with the promo code SAVEAWS. I will put that in the chat, and I'll also put that URL, it's a bit long, in the chat, and then you can find the dates, go there and register if you'd like. If that course is not exactly what you're looking for or you need other dates, don't worry. You can also get 25% off any other training, public or private, almost any other technology with promo code TRAIN25, and I'll put that in the chat too. I know that's a lot of information. We are running a lot of end of year deals right now. And let's meet Ryan. I've had the pleasure of working with Ryan for at least maybe 6 months to a year. He teaches a lot of our AWS courses with rave reviews. He's a cloud expert with 25 years of experience. He's also an AWS authorized instructor champion. He has pretty much every available AWS certification. And if we listed them all, I think we'd be here for more than an hour. So, we'll just say that that's all. And I think that's kind of a unicorn. I don't know how many people are able to boast that. So I really can't think of a better person to be leading this webinar. And luckily for us, he teaches AWS and other courses for Excel ILT.
Okay, so today's talk, so this is an architecting talk, but I have to tell you, obviously, we can't do the 3-day architecture that we would normally do. The Architecting on AWS course, it's a 3-day course. We would, of course, go much deeper, obviously, than we do in 1 hour. But the whole premise of architecting in AWS is actually based off of these, what we call 6 pillars of the well-architected framework. And that's kind of the core to everything we do in AWS. Quite frankly, whether you're talking specifically the Architecting on AWS course or certification as well, but really everything in AWS comes down to architecture. It doesn't matter if you're architecting, if you're designing a piece of software, like maybe you're a developer or a developer team, maybe you're security engineers, maybe you're data engineers, maybe you're data analysts, whatever it might be, there's probably some level of architecture taking place. Let me see, not able to view the screen. Can others just check in real quick before I get too far down this path? Are we able to see the screen okay?
Yes, Ryan, I can see it. Let me see if I can.
Wonderful. Okay, good. Just making sure. So we just had a comment in the chat. I just wanted to make sure. All good. Fantastic. Thank you, everybody. So in all reality, as we're designing and architecting solutions, and by the way, when you take training, you have the Architecting on AWS course. We've got other courses like data engineering. We've got courses around, around advanced architecting or data or DevOps or all these things. At the end of the day, they almost all come down to architecture, though. And so this is actually one of the things I tell people, no matter what discipline or what direction you're going to be heading in AWS, the Architecting on AWS course itself is actually a fundamental course that I would suggest everybody take at some point, because you don't have to be an architect for that class to be extremely valuable. You could be a developer, you could be a DevOps engineer, any number of things. And so at the end of the day, all this stuff comes down to architecture. And in Amazon, there's what we call the 6 pillars of the well-architected framework. And everything kind of comes back to this under most conditions. And so what we're talking about here is that there's kind of these different uh, best practices of sorts. And when I say that, I'm going to loosely talk about that. A best practice in AWS is not a recipe for success. A best practice in Amazon is not like a prescription. Okay. It's actually a set of principles that we kind of abide by. It's not about, we're not going to say under all conditions do this or do that. Okay. Because every situation is different. So it's more about being able to evaluate what outcome you want, right? Let's evaluate the design and meet the outcome. If that outcome is focused more on cost or security, or other things, these are all factors that we should be considering. It doesn't help us if we're building the most cost effective solution, but it's insecure. It doesn't help us if we're building the most secure solution that's not useful, right? I always tell people the most secure solution you can come up with. Imagine this. I write some really sensitive data to a hard drive. I take that hard drive, we encase it in a bunch of cement. We take that cement and we go find the deepest point in the ocean that we can find. And then we go a mile below that. We dig a mile down underneath the Earth's crust, bury it. Sure, it's secure. Nobody's getting access to it at that point, but nobody's getting access to it, even the people that need it, right? So we have to find some balance at all times, right? And so this is a great kind of guide to helping us achieve what we're trying to achieve in AWS through our designs. But we can't just have a myopic view of just one of these things. I can't just be a security-minded person only and not care about cost or not care about performance. But we also need to make sure we're still secure. So we need to find a balance of all of these things. And so Amazon has produced these 6 pillars of the well-architected framework, and each one of these actually calls out very specific best practices that we really should be looking at. Obviously, in 1 hour, I don't have time to go through all of these and give all kinds of great, examples to the degree that I would love to do. And of course, this is not an official AWS training course. That's what the coming Architecting on AWS course would be for. But here we're kind of just giving you kind of a big picture of some of the stuff that maybe matters and how we have to think about these things different in the cloud. So our way of thinking has to be substantially different than it is on premises. And we can get into the why that is if we had more time. But high level, you're essentially just renting these resources for a moment in time, right? So when I go to run some workload in AWS, I might pay to literally just run that action at that exact moment in time. Well, why does that matter in our architectures? Well, when I'm building things on premises, I'm buying hardware, I'm building these things out. It might even take me months to get that stuff right. In AWS, I just run the action and I pay for the action. So that means how I use it is probably going to be different. What kind of things does that action explicitly need access to? How does that affect my performance? Is there a positive or a negative to the performance here? These are all things we really kind of need to be looking at, right? If you go to build things in AWS, the way you built them on-prem, the way you used to build them, if you build them the same way here, you're probably going to have a huge expense that's going to come up, right? A huge expense. You're going to have some security concerns, and so on. And so we got to be careful with that. All right. So let's go and walk through a couple of these. I'm not going to be able to get through all of them in the hour that we have. I'm going to give you a couple of examples, though. We're going to talk about operational excellence. We'll talk about security. I'm actually going to jump down and talk a little bit about costs as well as just some examples of things that we need to consider. Okay. And so that's kind of the big picture there. I'm not going to get into all of these. We would be here for quite some time. So let me slightly shift gears. Let me share my other screen here. There we go. Perfect. So these are, again, this is an Amazon page here, the well-architected page from Amazon. In this case, it's kind of calls out each pillar. Okay. And there's just a real quick summary on each one. And then, of course, you could dive into each one of these. If I go into the operational excellence pillar, I click into it on the HTML, it's kind of a breakdown on all of this. And you'll see that there's actually best practices outlined here. Okay. And interestingly enough, the very first best practice is that we actually start with our customer needs. Go figure. A lot of traditional IT designs don't do this, ironically enough, right? In kind of I've been working in the IT landscape and the enterprise landscape, for over 25 years. The amount of times I've seen great, brilliant designs that don't meet the business requirements, it happens all the time. Okay. It's like we build in this vacuum, and we can't do that in the cloud. The whole point of the cloud, the whole point of a lot of this stuff is to actually fulfill the business requirements. And so we start with that, right? And then let's figure out what we need to build accordingly. And so we have these customer needs. Let's take a look at them and then we work backwards from the customer outcomes. So we actually start with, what is it that we are building? What is this thing that we're building here? And this is going to be unique on a case by case basis, right? The thing that we're producing here is going to be very different from one project to another project, or from one app to another app. And look at this right here, level of risk exposed if this is not established, right? I mean, this is going to cause a huge risk. And what kind of risk are we talking about? This could actually be security risks, cost risks, availability risks, all kinds of things that could actually stem from this if we aren't careful with how we manage this, right? And so the operational excellence pillar is actually all about operating the system. And this is an important one because I'm not just a trainer. Actually, I do plenty of training. We work great. We do a lot of different classes, but also a portion of my time is actually spent consulting with customers. And so I work with this space. I don't just train it. I actually work in it on a day by day basis with many customers. And the amount of times I'm hired for a project, this is absolutely crazy. The amount of times I've been hired for a project where a customer says, let's build X. Okay. So we build that, or focused on building that, I should say. And I start asking questions around operations. I start asking questions around how it's going to be supported. And I've had a few customers say, Ryan, we hired you to build this thing or help us build this thing. We didn't bring you on to work with support. Like, support is, we can deal with that later, and that's kind of the message. And I go, on the contrary, we can't build this until we know how we're going to run it. Okay. What is this going to look like from a running perspective? And then work our way backwards. This is the first best practice that Amazon actually calls out. We say, start with the customer needs and work our way backwards. And these customer outcomes are not just a product. The outcomes include things like resiliency requirements and the ability to scale, right? The ability to monitor and observe what's going on. Those are all requirements that we have to start with and work our way back from this. I could recommend the best solution in existence on some need, but if you can't support it as an organization, right? So example, what if we build out this whole thing and it's built all in Python code and it's all this, but you don't have a single Python developer on staff? Makes no sense, right? So that's a very simple best practice, but it's sometimes a lot harder and a lot less obvious than people will give it credit for. Operational needs are very, very important. So we start here. We say, how are we going to run the system that we're going to build out, and then work our way backwards from that, right? And so we have to start here. And this is not the fancy technical stuff, right? This doesn't always get us down this exciting technical path, but it's a must, right? We have to start with the business mindset and say, what is the problem we're solving, and how are we going to solve it? And is the solution actually viable? There's 100 ways to solve these problems. And we don't want to choose the solution that doesn't work by operations, right? So it's kind of frustrating when I work with a customer or something like that, where they say, let's ignore operations. And I can't. We can't know how to build this without operations. We have to start with that, actually, and then work our way into the actual build out. Okay, we can't just build in a vacuum. So this is a big one. Now, these pillars are again big high level concepts, right? And so I kind of just talking about observability, or operational rather. Operational includes the concept of observability as well. You see down here we have we have organizational, we got preparing, we got operate and evolve. Inside of these, you're going to have some stuff around observability, around monitoring. Without getting into all the nuances here, we could spend all day just on one pillar if we really wanted to. We're going to make this kind of brief here, and we're going to move on to other pillars. But the thing is, we have to start here and then work our way out from operations. It doesn't matter if we build something super secure, if we build something that is extremely cost effective, if we can't run it, right? So we start here, and then inside of this includes things like monitoring, and a newer term that's emerged kind of over the last 5 to 10 years is this phrase called observability. Okay. Observability is different than monitoring. Monitoring is about metrics a lot of times. Okay. CPU spikes and how much disk space I have and those things. Those are classic monitoring metrics. I don't know if anybody here remembers the old Sherlock Holmes shows, or actually there was even a movie more recently on that. But there's a saying that Sherlock Holmes used to actually say, and it would be, "You see, but you do not observe." And unfortunately, this also happens a lot in IT, right? In the technical landscape. Okay, we have all these metrics, but what do they mean? Right? Are they? What is the bigger picture? What is that picture that's being painted with those metrics? Is there some sort of analytics we could be doing against those metrics to give us some sort of bigger understanding around all of that? And so we need to actually understand the data more than just capture the data. And so there's actually a lot of tools in Amazon that actually help us with this. And so if I kind of come back here, under observability, we've got this terminology. It's actually an acronym called MELT. Metrics, events, logs, and traces. This is what observability actually consists of. So we've got metrics, which are typically captured in a product in Amazon called CloudWatch. We've got events, which are event handling or event-driven workloads, things like that. Things that occur in our environment are events. A metric might just be, let's say, CPU load is anywhere between 0 and 100%. It's constantly moving, right? That's not an event in time, right? An event is something occurred, right? So maybe, I don't know, maybe a file was written, some data was updated, something was deleted, or any number of things. Those can all be events that occur. And those events are opportunities to do something at the moment that event occurs. And so there's products in Amazon designed to handle and route those events and initiate actions based on those events. So as an example, I can write something to S3. Now, if you're not familiar with S3, we can talk all about that in other training sessions, but it's basically a place to store some data. When data is written to S3, I could have an event automatically kick off a data processing job to convert that data and load it into a database. So now all I need to do is drop that data on S3 and it ends up in the database. Drop some more data on S3, it ends up in the database. Okay. So events are things that are a moment in time, something occurs, and I can automate against that. Logs are going to be actual actions that are happening, outcomes, stuff that's being written to the screen, any number of things. And so those all need to be captured as well. And there's basically a couple different logging systems in Amazon, depending on how we're using them and so on. And so, of course, we can evaluate those logs. I have a very strong background in security. And I'll tell you, I got very heavily involved in data about 10 years ago. I started really focusing on big data, data analytics, and machine learning because of security, interestingly enough. And what got me there was logs, interestingly enough, is I kind of came to this realization that almost every company out there did a great job at collecting logs. But just because you collect them doesn't mean you're doing anything with them. So the majority of companies collected logs, but did a terrible job at doing anything with them. And it's like, this is live information. This is stuff you have knowledge about your environment that's going on right now, and you're not doing anything with it. In fact, there's some security stuff out there that might actually say that up to 80% of our security posture comes from these logs. And if we're not using these logs, we're missing the boat on 80% of our security. Okay. So we should be processing these in near real time. We should be analyzing these, apply machine learning to the logs, do analysis of these logs right now. Fortunately, there's actually services in Amazon that do exactly that make this actually a fairly easy job to do. So these logs contain very valuable information, and we can have automated systems that do that. So here's the thing that we start to see with the cloud. The cloud is not virtual machines. Okay. Virtual machines existed long before AWS was around. Okay. We could do virtual machines many years prior. Okay. What makes cloud so special, whether we're talking AWS or Google or Azure, OCI, I mean, there's a lot of cloud providers, right? But what makes cloud in general so interesting is it's not just virtual machines. It's not just somebody else's data center. I know some people say that. It's the fact that you get potentially decades of research and development incorporated in some product that you're able to use and just use it like that, right? And so some of these products, it's like, hey, I need to analyze logs in near real time and apply machine learning to them. Guess what? Amazon already does that. You don't actually need to develop that solution. It's already there. In fact, in some cases, it's just a couple of checks to the box and you can make it happen. We'll talk about that. There's actually a product in Amazon called Guard Duty that will analyze these logs from a security perspective and help you understand anomalies inside of your logs, right? Things that are going on, and say, wait a second, it looks like somebody's doing a reconnaissance for some attack, for some future attack, or somebody's right now in the middle of attacking you right now, and here's some stuff that's going on, and we're seeing it in the logs. So you don't have to do that work, right? And this is the beauty of the cloud, is you're actually able to take advantage of 20, even 30 years of knowledge gained at Amazon and all this research and development with some of the brightest, best people in the world on this stuff. And you're able to just use it, right? Nothing to install in a lot of cases. It's literally just use it. Whereas historically, if I did the stuff on premises, I would have to go buy expensive appliances, install those, set them up, pay for professional installation. We might not even get rolling on that for 6 months. And meanwhile, it's a massive investment to even get to that point. Meanwhile, in the cloud, it's a checkbox, or it's a single API call, right? It's a single command line entry, something like that. Very simple stuff a lot of times. Traces are for microservices, API tracing and things. So if you have microservices where you have service A talking to service B, talking to service C, talking to service D, tracing that request through the system, being able to diagnose which of those systems is maybe the problem. Maybe service A, the front end, it looks like something is slow, but is it A, B, C, or D that's actually causing the slowness? Something like tracing is actually a part of that landscape to be able to identify where that slowness is coming from, where the latencies are coming from, the load, and all that. And so we need to use traces. Well, again, there's a service in Amazon that just does this for us. That's called X-Ray. And so we can incorporate a lot of these services and get up to speed on things that normally would have taken maybe months, many months, maybe even in some cases years, that are already built. And we could get this stuff online in a matter of minutes or hours or days versus weeks, months, or years. Okay. And so that's a huge reason we use the cloud, is to be able to leverage Amazon's research and development here. Okay. And so we're going to kind of hone in now for just a second. I mentioned I have some background in security. I'll talk about security pillar for just a second here. I'm not going to bore you on this. I mean, some of you are interested in security, some of you aren't, but we all need to have some level of interest. And it's important. It's not just cliche. It's a very important thing. Security is everybody's responsibility. If you're a developer, you have the ability of making a very insecure load in the code. If you're an architect, we can make insecure designs on that front, right? Things like that. So in that regard, we're all responsible for this. And I want you to understand there's this concept of zero trust. I'm not going to get into all the details of this. And I could teach zero trust for a couple of hours if we needed to a security team. But here we're going to just give you the really high level highlights almost of it. And the general idea here is not just that you don't trust anybody. In fact, this doesn't mean I don't trust people. Okay. We should hope that for the most part, we have employees in our company that we can trust. Right? Now, you can't say you can do that blindly. Okay. But this isn't about having no trust with people. But what we're saying is not from a human perspective, from an action perspective. Every single action that takes place should be authenticated and should be approved. Okay, so here authorized is actually the official term for that. So here's the general concept. Chances are, if you work for a larger enterprise, but maybe not, a lot of people have these key cards or badges or something, right? And maybe you need that to even enter the building. And then maybe there's a lobby. And then maybe you have to use that card to enter the elevator and to go to a specific floor. And then maybe you have to use that card to enter certain doors, right? Well, every time that's happening, you are re-authenticating. You're proving that you are who you say you are, okay? You're not just blindly walking around the building. You're able to say every time, this is who I am. And then in the process of doing that, do I have permission to open this door? Do I have permission to go in this elevator? Do I have permission to go wherever, right? And zero trust would say this has to happen on any and every action that takes place. that you have to re-authenticate. There's not like a central login where I just log in and I'm blindly allowed access to everything, right? It's every time I do something, there's authentication taking place. And then not only am I authenticated, then I'm reevaluated of, do I actually have permissions to do this exact thing that I'm trying to do? That's what zero trust is. Versus just letting everybody in the front door and say, well, if you're in the front door, you're allowed. This is the problem, actually, is traditional IT does what I just described in the second half of that. Traditional IT, you tend to have classic firewalls. And once you're through the firewall and you're on the other side, you're trusted. Meaning if you're on this like trusted network inside, you're just blindly trusted. Do whatever you want to do inside of that network and you're trusted. Zero trust doesn't do that. Well, Amazon is built with zero trust in mind. Unfortunately, I've seen a lot of customers take a nice, really, really high quality, secure environment using zero trust and degrade it in Amazon. In other words, they take this great starting point and they do away with zero trust and they start doing things in the old way. They start doing things with subnets and firewalls and managing things in that capacity, which AWS is actually not designed to be managed in that capacity. I mean, you can, but even then, even if we're dealing with traditional network designs, we can do things in a zero trust way. And so the point is that I've actually seen, ironically enough, I've seen security teams make Amazon less secure because they applied old ways of thinking to this new environment. You can't take your knowledge. Like I said, I've been doing this stuff for 25 plus years in the enterprise, but stuff that I learned in that first decade, a lot of it doesn't apply here, or is quite frankly the exact opposite the way we should be doing it in the cloud. And this is why training is so important, because without that training, you can make things work the way you made them work on-prem. You can make things work the way you've always made them work, and they will probably work. They might be expensive, and the administrative overhead might be absolutely astronomical. And in the process, you may have actually degraded the security. So we need to know how to do this stuff well and correct and right, because if we don't, we're actually taking something that is really hardened and making it less secure. And again, the amount of times I've seen security teams, in the interest of security, good intentions, I've seen people actually degrade the security in the system. Okay. I actually see raised hand. We've got limited time, so I'll take a couple questions, but go ahead. Raise hand. Go for it if you want to open your mic. I don't know if you can, if your mics are not locked. Not sure. Maybe it's only one-way audio. I'm not sure. It's a webinar, so normally so if you want to type something in the chat. That's probably the best way to do it. I'm kind of monitoring the chat, and if there's something you want to throw in there, go for it.
Yeah, thanks, Ryan.
Absolutely. Yeah.
Typing in chat
is probably the best way to do it.
Is it?
Yeah, it's probably the best way with this many people. I mean, we've got a pretty good size group here, so I think opening the mics would probably not be a great idea. So
and we do.
Yeah. Absolutely. So go ahead and drop it in the chat, and if it's something I can kind of slip into the mix of the conversation, I'd be glad to do so. All right. Awesome. So yeah, zero trust is something that that we want to try and adhere to, but we have to fully understand it. And that's a kind of an important piece to this. So just real quick, I want to show you something about this when it comes to government standards actually on this front. So there's actually a standard on zero trust by the NIST. And if you're not familiar with the NIST, it's a government standards organization, and they have a standard defining zero trust. And so there's something here that's very interesting. This is just an abstract summary. If you want to actually go look at the full documentation of this, of course you could. Let me just go ahead and drop this in the chat real quick. All right. So yeah, absolutely. Inger, yeah, I'm going to go ahead and give you some of these links. Absolutely. So this is a good one right here. So I'll start with this one, and I'll kind of also go back, and if there's anything else, in fact, while I'm at it, let me go ahead and give you the well-architected link here. I'm just going to throw that one in the chat as well while I'm thinking about it. So that's in there. And of course, you can go from there. You can go to any of the pillars you want to go dive into. Okay. All right. So the zero trust, this is just a summary. I'm not going to read this whole thing. Of course, you can read this for yourself. The link is in the chat. But I want to talk about some of this stuff. Zero trust is a response to enterprise network trends that include remote users, right? So the thing is, people have been distributed. People have stopped coming in the office very commonly. or not coming in the office as often. So network location, or actually geographic location, may not be as the same as it once was. But look at this right here. There's an interesting statement here. Zero Trust focuses on protecting the resources. Okay. Oh, they're not coming through the chat. Okay. I'm not sure how I can get those out. But yeah, we'll see what we can do. All right. So if you can't, you can just do a search for NIST Zero Trust, and this should come up. Okay. Also, if you do a search for AWS Well Architected, it'll be one of the first search results that you'll come up with. Okay. So Zero Trust is focused on protecting the resources. So this will be actually like protecting the data itself, as an example, saying if you want access to this data, you have to meet all these conditions. And if you don't meet these conditions, you don't have access to it. I'm not going to necessarily care so much about what network address you're coming from, what subnet you're coming from, what that's not a trusted. I don't want a trusted network. Okay. In fact, statistically, 60%, over 60% of attacks come from the inside. Now, some people mistakenly think that means that my employees are the attack source. Sometimes they could be, but by coming from the inside, we mean that they were trusted somehow. So if I break an application and I end up on the trusted network, that's the problem we're trying to avoid, right? We want to make sure that even if you break that application, that you're not somehow landing on some trusted network. Okay. There's no such thing as a trusted network in a zero trust environment. Oh, cool. It looks like my teammates have actually been posting the links there in the chat. Hopefully that helps. Maybe that'll work for you. So look at this though. Okay. Zero Trust focuses on protecting the resources. Okay. Not network segments. The network segment is no longer the prime component of security in Zero Trust. So AWS is a Zero Trust environment. By the way, AWS is not the only one, but when we're talking AWS, this is how we want to design things. Okay, so I'm going to kind of leave this alone. This isn't a security class. I just want to touch on this, that, hey, you know what? The way we approach these problems is very different than the way we used to do it on premises. And if we take the old way of doing it, we will directly cause security risks in the cloud if we're not careful. Okay. The amount of teams I've encountered as a consultant where I've seen this firsthand, where the team is in the interest of security trying to do what they think is right, but they haven't had the necessary training. And so that, of course, everything kind of falls apart. Right. And their way of thinking needs to change. Okay. And so this is really, really an important thing. And this kind of carries through not just with security. Our way of thinking has to change across the board on all of these pillars. Okay. Security just being one of those pillars. All right. So I'll move on. But yeah, this is an important pillar to kind of address there. Right. And then we've got principle of least access. This kind of goes along with Zero Trust. Principle of least access basically just means when I grant access, I only grant what I need and nothing more. Okay. And we do that through policies and roles and things like that in AWS. Now, I've pulled up a couple policy examples. I'll show you just kind of what these might look like. But I want you to understand that by default, nothing has access to anything in AWS. Because of Zero Trust, no service in Amazon has access to another service. No service has access to any resource in your account. So just because you're having service A talking to service B in AWS, it doesn't mean they can talk. Just because they're both AWS means nothing. If service A is not trusted, you don't have a policy set up to grant service A the ability to talk to service B, they cannot. Okay. There is no default open access to anything in AWS. It is completely locked down. And then you specifically say what you need to open up. And so the way you open that up is through policies. So policies are more of an allow scenario versus a deny scenario. You can do denies and strategic advanced things, but mostly it's an allow concept. Only allow what you need and nothing more. Okay. And so I'll kind of share with you kind of some of these examples, and then we'll move on to some other topics. But one thing I want to point out is I mentioned how in the key card example, you might swipe that key card at every door. Okay. Just as an example. Okay. And to get into that door, you got to reprove who you are. Okay. Well, this is happening in AWS as well. Again, because of Zero Trust, we have to authenticate every single action every single time. So there are completely dynamic credentials. These are in the forms of keys, API management, and keys that take place. And these keys are generated and cycled through very aggressively. By default, when I do what we call assume a role in AWS. We'll get into that in our architecture class. But when I do this action, I have to kind of think of it as like a persona, like you kind of become this role, and that's what has the permissions. So I say you, I don't mean the human being. The service takes on that role, and that's what gives that service the access or the permissions that it needs. Well, in the process of doing that, credentials are actually generated. And those credentials by default last no more than an hour. These credentials could be shortened down to 15 minutes. They could, under situations, could be all the way up to 36 hours. And you can define this. But the point is, those credentials are generated. And then every single API request actually has a fresh signature on every single request. Those credentials are not used by themselves. Those credentials are used as part of an algorithm to actually generate a unique signature for every single action we do. Every single API call we do has a unique signature to it. Okay. Very different than just trusting a network. Okay. We're proving that we are, who we say we are when it comes to that, whether that's a service, whether that's an application, whether that's a person. At all times, you have to reprove that every single action. And then, of course, that's all logged and monitored and, all of that, right? We have a full observability around all of that. And so let me just kind of briefly show you some examples of IAM policies here that I've pulled up. So Amazon's got a nice policy example list here for anybody that's interested in kind of understanding these a little bit more. I put the link in the chat. Maybe that can get republished there. Oops, sorry, 1 second. Okay. So these are some examples. Let me just kind of show you. Allow access during a specific range of dates. Okay. So there's this policy here that says, hey, there's this particular service, and it's only allowed access during this time frame. So here's a scenario I want us just to kind of be aware of. I can actually make policies in Amazon that says you can do this one action during this 1 hour window of time if I want. Okay. And if it's outside of that hour, it's access denied. All right. I can have policies that and that policy may not just be blind access. It might be like, I can do this one request against this one piece of information for this 1 hour. Okay. Aside from credentials, right? Credentials are going to be expiring after an hour at most. But again, also those credentials are used to generate that signature. And then from a permissions perspective, those permissions can be very dynamic and have very short windows of time, perhaps. So there's a bunch of different policies in here. Now you'll be taught, if you don't know what DynamoDB is, this is talked about in the architecting class. But DynamoDB is a NoSQL database. If you know nothing more than that, that's fine. Okay, it's a database, NoSQL. We're not going to get into all that. But there's a policy here, and let's just take a quick look at this policy briefly. We're saying, hey, we're going to allow these actions, and these actions are specifically the ability to list stuff, and then describe commands or read-only metadata kind of commands. Okay, and so we can do all those. And then we might also say, you know what, we can only do these actions against this specific table. So I might say I have this NoSQL table and I can do batch get operations. I can do these actions, right? So I might have a service that needs to be able to do these things. But again, it's allow specific. Without this allow, these things can't happen. Okay. So these are just kind of the syntax. As you notice, though, it's more like code, right? It's more like it's like a level of programming to some degree. And so there's a level of understanding that we actually can run these through things like DevOps pipelines, CI/CD pipelines, version control, all of those things around these permissions. And this is what a permission looks like in AWS. Okay, we get into this a little bit in the architecting class, and kind of you would know how to read these at the very least, how to really understand these, and how to leverage various conditions and other things around that. Okay, there is a separate security engineering course that goes into much greater depth on this, though, right, for AWS. But at least in the architecture class, you're going to go high level on this. Okay. Okay. So that's kind of the main thing there. All right. Oh, is Terraform supported? Absolutely. 100% yes. AWS fully supports Terraform. Yeah. And for those of you that aren't familiar with Terraform, that's discussion for another day. Okay. But yes, 100%. So a couple of things I want to also talk about, though, is there's this kind of new breed of tools. I say new breed. I mean, in Amazon, these have actually been around in some cases for a very long time. but it's a new breed in the sense that a lot of people are just finding out about these things, or maybe they're just new to AWS and so they don't know about these things. These are all tools that actually leverage machine learning. They use AI. AI has kind of been the topic of conversation for a lot of people, in a lot of places for the last year or two. It's really come on the scene. That's a different kind of AI. Okay, the stuff that everybody's talking about is what we call generative AI, right? Generative AI means it's generating content, right? It's creating stuff, new works. This AI has actually been around for quite some time, is really intelligent, but it's more about things like, hey, let's identify anomalies. Let's look at something that's not normal. So, what if the system can learn what normal is in your environment? It learns, okay, every Monday morning there's this spike that happens in this capacity, and that's normal, right? But there's various things that are normal. But then what about things that aren't normal? Okay. So there's anomaly detection across the board. There's a whole bunch of services that support anomaly detection throughout AWS. Again, the beauty here is we don't have to codify these things, right? This is stuff where it's like, you want anomaly detection? Just turn it on. Okay. Now, in some of those cases, there are fees for these things. You have to be willing to pay for it, but the beauty is you don't have to do the R&D for it. You don't have to go set this up. You don't have to install anything. There's no licensing. It's usually paid for usage. Okay. So a smaller environment pays less, a bigger environment pays more, depending on how it's being used, right? Amazon Guard Duty actually analyzes your logs. It actually looks at DNS lookup logs. It looks at network logs. It looks at API logs, looks at them all together to paint a picture, and it will alert you of anomalies and things that are going on in your environment, or things that look like a specific type of attack. It'll let you know. So the thing is, no longer am I looking at purely things like network devices to look for network packets and attacks at the network level, right? We're actually looking at things from a much more intelligent perspective than that. Attackers today aren't manipulating IP packets like they once were. Now it's much more strategic attacks around leveraging services and being smarter about it to make it look more like a human being or this or that, right? So finding those things, we have to kind of match what the attackers are doing with more intelligent software. Okay. Amazon Macy, this one's really cool. I've got a customer that has a really neat story. I'm going to tell you briefly on this. I'll try and summarize it. But this product right here will actually, first off, it'll scan your data and look for sensitive information. Let's say you wanted to find social security numbers, credit card numbers, things like that throughout your data, and you want to find it in any places that maybe you didn't know it existed, right? Most basic, simplistic example, what if I had a document that said my social security number is, and then there's a number, but it doesn't have any dashes? It wouldn't have matched any kind of pattern recognition. We need smarts to understand the context, to know that that is a social security number. And so you need machine learning tools that'll do that. And so Macy will actually look for that. A second thing that Macy will actually do is look at human behavior. This is a really cool one. So customer of mine, a couple years back, they had a salesperson that had access to a lot of customer data, completely legitimate access, totally within the security scope of what this person should be doing. So they had legitimate access. They didn't have to do anything special. But suddenly one day, this one person was downloading a whole bunch of customer data, like unusually in a unique, unusual, anomalous way. Okay, completely within the permissions. Long story short, this person was actually downloading all the customer data from the company. They had accepted a position with another company, and they were stealing customer data to take over there. This customer that was using Macy identified it in real time. Like as this stuff was happening, they go, what's going on? Why is this person just suddenly sucking down a bunch of information from our data sources? And although they have permissions to it, this is unusual. Okay. Macy caught it, alerted. Okay. Detective is a great tool for like investigating root cause or even potential vulnerabilities in your environment. It'll detect. It's kind of like an investigator, right? It's kind of going out and investigating things in your environment. Again, using full artificial intelligence, machine learning sense here to find these things in your environment, because these are much harder, sometimes much harder to find in the cloud than they were at a different era, right? It used to be I could just make sure my routes were safe, my firewalls were safe, and that was kind of the bulk of our focus. Very different world now. A lot of this stuff doesn't even deal with networks, okay? Even down to the code level. there's actually a product that will analyze your code for vulnerabilities in your code. Okay, making sure that proper validation's happening, that you're not vulnerable to things like injections and SQL injections and different types of attacks like that, right? So there's these tools that will govern your environment in a totally new and different way than we're used to. We're not going to just use firewalls and intrusion prevention systems like we once did at the network level. We're way past that. We're way more advanced than just analyzing network packets. Okay, and the network access analyzer is more about reachability, like what has access to what in our network, and what shouldn't have access to certain things it does, right? So then we're going to kind of totally shift gears, okay, going into cost. So we talked about operational, we talked about security. I want to briefly talk about cost. We've got about 14 minutes, it looks like. So cost is an interesting one. What I'm going to do is do a little exercise with us here. This is going to be kind of a fun little exercise. So I've got two operational scenarios that I am presenting here, and I want us to kind of work through what those costs might look like. Okay. And again, in the architecting classes, you kind of learn how to do this yourself. Okay. I'm going to kind of simplify it. So don't think it's always as simple as I'm presenting here. This is just a very unique scenario I wanted to present. Well, in this scenario, we have one case that's like a fairly high rate of writes coming in. So you have this data, maybe this is data being generated from logs or sensors, IoT devices, whatever the situation. Maybe you got mobile apps, but I've got these 300 writes per second. Okay. And maybe this is on average. So it's a continual 300 writes per second, every minute, every hour, every day. Okay. Nonstop. All right. And so these writes are coming in. This is on average. So maybe some moments there's less, some moments there's more, but on average, we've discovered it's about 300 writes per second. Each write is only about a K. Okay. Fairly small blocks of information here, but it's a fairly high rate. Okay. Now I say fairly high. I mean, there's things I can do in AWS that are literally millions of writes per second. Okay. So this isn't high when it comes to AWS. There's capabilities of me doing amazing things here, but still 300 writes per second is nothing to laugh at. So I have these 1K writes coming in. We have a total of about 77 million writes per month. Okay. Total amount of data that we're dealing with here is about 777 gigs, because if you look at this 1K, it's just take this number and add 1K to it or multiply it by 1K and you end up with the same number, just a couple extra zeros, right? So we have 777 gigs per month being ingested through this model, all right? And I want to point out this other scenario that we've got here is actually the same amount of data. My point is the actual amount of data we have to store is the same. The thing that changes between these two is the rate and the size of the writes. So I want to highlight that. So the only thing that's different between these is up here. You see this is only 3 writes per second, but the writes are bigger. Okay. So smaller writes, many more of them. Bigger writes, fewer of them. Okay. Same total aggregate data. So what should we choose here? Should we use S3 to ingest this data, or should we use DynamoDB? Now there's other ways. I mean, there's plenty of, there's like 10 different places I could probably think of right now off the top of my head where I could send this data. Okay. But the point is I want to receive this data and I want to store it for long-term use. Okay. In some capacity. And that could be either one of these. These are not, by the way, S3 is not a database, but it has the capability of being queried and being used like a database. S3 is labeled as DynamoDB is, however, labeled as a database, but it can also just be used to store and query data. Okay. I mean, these are both under a heading of what I like to call data store. Whether it's storage, whether it's a database, databases are just a fancy way to store and retrieve data. All right. Databases are still just storage as well. Okay. So they're both storage solutions. So the question is, which one makes the most sense? Well, we're going to compare these two scenarios and kind of show you the nuanceable differences between these. And so we're going to just pull up the pricing calculator in AWS just to kind of show you the effect of this. Okay. So there's this calculator in AWS. I'm going to give you a link to this as well. But again, if you just did a simple Google search of AWS pricing calculator, you would come up with this probably pretty quickly in your Google search. So I'm going to create an estimate here. Okay. So what we're going to do is we're going to do the first scenario, right? And the first scenario was 300 writes per second with 1K writes. All right. So we're going to pull up S3. I'm just going to do the most basic situation here. Now, if I choose some of these other options, it would actually get more expensive than what I'm about to show you. Okay. So 300 writes a second. I want to point out S3 is capable of much more than this. Technically speaking, S3 has this capability of what we call partitions, and we can do multiple partitions. But a single partition can handle 3,500 writes per second. Okay. So 300 writes per second is really nothing for S3. S3 can handle this just fine. Okay. So we're going to say, you know what? We are doing 300 writes per second. That is a total in the whole month. It's a total of 77 million, right? So 777, 600,000. Okay. So just the operations to write this data to S3 is $3,888 a month. And this is just the sheer cost of writing it to S3. Okay, so this is a write cost basically. It's an operations charge. Okay, I haven't even paid for the storage yet, but here's what's kind of crazy. If I put the storage amount in here, which is 777 gigs, doesn't look like the price changed a whole lot. Well, let's look at the calculations for this. Look at this. The actual storage cost for 777 gigs here is just under $18. So I'm going to pay $18 a month to $18 a month to store this data. But for $18 a month worth of data, I'm going to pay just under $4,000 to operate $18 of data. That sounds kind of off, doesn't it? It doesn't seem like it's a very good solution. So I've had customers that say, Ryan, S3 is expensive. Or I've had other customers that say S3 is cheap. They say, hey, Ryan, S3 is cheap. And so they just use S3 for everything. You can see here, architecturally, this is a bad choice. Right? I hope this is pretty obvious that if I'm paying this kind of money, it's only $18 worth of storage, but I'm paying almost $4,000 to operate it. There's something that doesn't work right there. Okay. So let's actually switch gears and do this with DynamoDB instead. Okay. And let's use DynamoDB to ingest this data. And so there's different ways I could set up DynamoDB. Because we're just kind of doing a constant stream here, I'm just going to use what we call provisioned capacity. Now, there's actually another way called on-demand. I'm going to actually briefly show you this here in a minute because on-demand is going to be more expensive, ironically enough. And this is also an important thing. I've had people tell me that on-demand is always cheaper. No, it's not. You have to know the situation, okay? So it's all about architecting, okay? So what I'm going to do is I'm going to come down here and I'm going to say that we have writes. Okay. So these writes coming in are 300 writes per second, right? And it's not going to even worry about peaks. So we're just going to do a consistent, just make the numbers easy. I'm not going to worry about any kind of peak or bursts or any of that kind of stuff. Okay. And we're not doing any kind of reserved capacity, which we could talk about another time. Okay. And then the data storage size, we're dealing with a total of 777 gigs, okay, worth of storage. So you see here, just the storage is actually a lot more expensive than S3 was. Remember how S3, the storage was $18 or a little less? Here, the storage is going to cost me under $200. So it's actually quite a bit more on the storage cost. In fact, DynamoDB storage is about 10 times. It's actually a little bit more than 10 times the cost of S3, okay? And so, wait a second, this is an interesting thing, right? But my operations of all of this are substantially cheaper, actually. In fact, this shows you all the math that took place. I'm not going to walk through it all. But we look down here, my total monthly cost is $339. So even though the storage is 10 times more than that of S3, the operations are cheaper. I'm doing the same number of operations, the same amount of data, the same amount of everything. But instead of it being almost $4,000, it's $339. So this is architecture. Okay, this is why architecture is so crucial for us to understand how to figure these things out, because I can make it expensive. I can make it substantially less expensive. Now, by the way, that's scenario one. Now we've got about 5 minutes here. I think I can get in through scenario two for us here. Let's just take a quick look at scenario two. We'll go back to S3, okay? But in this case, I want to remind you what scenario two consisted of. without switching back and forth on my slides, scenario 2 was only 3 writes per second. And it was 100K writes. Okay, so bigger writes, fewer of them. Still a constant clip though, right? Still 3 writes a second forever. Okay. But what we're going to do is come in here and we're going to take a look at that. Now, the actual storage here. Okay, so we're going to do a total of now it's fewer writes. Okay, so instead of 300 writes a second, it's 3 writes a second, which comes out to be 7,776,000 writes per month. Okay, and this is where I'm not going to get into all these other things. The put operations for this are $38. Okay. And then let's talk about the actual storage though. We're still talking the same amount of storage as we did before, right? So it's 777 gigs. So that's the other $18. Okay. So if I break this down, I've got $18 for my storage and I've got $38 for my operations. Same amount of data, but the operations changed. That mechanism, that thing that we want to look at is very different, right? So the workload is substantially different. As an architect, I need to look at this and go, what kind of workload are we dealing with? Are we dealing with a fairly high rate of writes, or are we dealing with fairly low rate of writes? Now I want to point out 3 writes a second is cheap in S3. Okay, 3 writes a second is fairly cheap in S3. But 300 writes a second is a very different ballgame, right? And so we'll wrap this up. We have about 3 minutes. I want to actually do one more, and I'm going to show you the same scenario once again for scenario 2 with DynamoDB, and then we'll be done. Okay. So DynamoDB, let's just see if we can do this here quickly. Provision capacity. Okay. Again, we're not going to worry about all these little details. You can learn these things in classes later, another time. Storage size, 777 gigs. Okay, worth of storage. As far as writes, now, by the way, I haven't even addressed reads. We're just pricing out writes right now. That's all we've been doing. Okay. So we're going to come back here again, our write rate. Okay. Now it's 3 writes per second, 3 writes per second. We're not going to worry about peaks, and we're not going to worry about contracts and things like that. Okay. So just kind of simplify it. So this scenario, we're looking at still about $200 a month. Okay. So we were able to do this in S3 for about $50 a month. We were able to do it in DynamoDB for $200. So in scenario 1, let me recap on this real quick. Scenario 1, S3 cost me almost $4,000. Scenario 2, S3 cost me $50. I'm kind of rounding here. Okay. In scenario 1, DynamoDB cost me 300 something. In scenario 2, DynamoDB still cost me like 200 something. Okay. There may be some little things here I may have missed a little bit here and there, but at the end of the day, you can start to see where under one condition, S3 was way more expensive. In the other condition, S3 was the cheaper choice. Can I just make a rule that says always use S3 or always use DynamoDB? Of course not. By the way, the same exercise, I'm going to push it out even further. I'm going to use other products too. I'm going to compare this with other solutions like Kinesis or there's a whole slew of products that we could go compare these things through and say which was actually the best. I only narrowed it down to 2 for the simplicity of this webinar. Okay. But in reality, there may be 10 possible storage options that we could use here, and we need to be able to understand which one's the best one to choose under that situation. And that's the message. Okay. That is the key message that we need to understand is at the end of the day, we have, as architects, have to contemplate all of these pillars. Okay. So let me just roll back real quick. These pillars, the 6 pillars of the well-architected framework, we need to look at all of these things and make decisions. And those decisions are not just in a vacuum. I can't just do it based on cost. So then my next thing is let's step back and go, okay, I chose S3 for this scenario. That's great. Now, how do we apply the security pillar to S3? How do we apply the reliability pillar and so on, all these things. And that's how we're going to handle that. Okay. So that's, I'm going to say that's good. Okay. We're done. We're out of time. And that's pretty much everything I plan to address. So I think I kind of timed that pretty well. So I'm glad to have you here. I'm glad you were able to join us. Now, if you want to kind of learn more about all these things, obviously this is what those architecture classes are for.